So we're here at the IDTechEx show, and I'm here with Peter from Agfa. Peter, good to see you
hello.
again.
Oh, yes,
tell us a bit about what Agfa's doing in print electronics.
Yeah. Well, we have a number of products actually. We work already for quite a time on the conductive polymers, which are well known, the P.PSS line, where we are really a global leader in that market. In printed electronics, that's mainly used for printing exactly the ITO where you want it. So no messing around with ITO film, you just print the clear conductor where you want it, and you add the other circuitry, typically silver circuitry, to make the full circuit. Actually, you have that there on display.
Great.
So this is typically the way automotive is growing, also for typically now in Japan and so on. So this is a typical air conditioning control panel. Behind it,
so are they printing? How are you getting the material on there?
Actually, it's done at this stage still by integrating printed polyester, where you see the silver trace is printed, and you see the areas where you have the backlit keys in the panel.
Oh, yeah.
There, this is printed with conductive polymer. And actually here in this case we combine our nano silver, which is very conductive at very low dry film thicknesses. You can very easily and reliably interconnect it with the screen printed P.PSS layer.
Right.
Because of the very low dry film thickness for the nano silver. Because that's the other product that we have then, that's the conductive nano silver. What is the big difference if you compare to what traditional flakes offer? You have a typical dry film thickness of around 10 to 15 micron. We have the same conductivity at only 1 micron. Again, what does this mean for printed electronics? Very clearly, you just reduce the amount of silver you need by a factor of 2 or 3 for typical applications. This is a printed NFC label, an excellent application also for our product, where you see that you, on the one hand, you want to print a very highly conductive antenna, which is an NFC antenna. So this is a highly conductive element where you want where you can use the nano silver for. But at the same time, you see there is a hybrid electronics. There's a chip. So you also want the very fine circuitry, which you can also easily achieve by printing the nano silver.
Is that a temperature sensor?
That's a temperature sensor. You complete it with a printed battery. In this stage, it's attached, but you can also print it, and it's a temperature logger that you can use.
Right. Great.
And finally, the last group of products that we have is a kind of crossover, because this is really additive printing, but Agfa is also already producing a lot of products for the typical traditional printed circuit board industry. And what we have here is we are now bringing to the market inkjet ink, which is used for legend printing, so that's the white lettering that you see on the board. And secondly, and that's half in between the additive printing of the circuitry and the subtractive patterning of the copper, this is inkjet printed, Agfa inkjet printed etch resist. So instead of using a masking technology with a photoresist and a mask, you directly print with high resolution using inkjet the pattern that you want to keep on the copper. So this goes directly into the etching bath, and you strip the copper first, or you etch the copper away, you strip the resist, and your circuit is ready.
And what's the benefit of using inkjet printing for that?
Actually, you cut out a number of steps, because normally you have to take the copper, you coat it completely with dry film resist, you then image the resist with a photo mask. You have to develop the resist, and only then you can go into the etching, in the etching solution for the copper. In this case, you just directly print, and even because it's digital printing on a 1:1 scale, you just print the pattern you want, and you go into the plating, into the etching bath. So actually, you're cutting out a number of steps, a lot of steps. And you can go to, you can more easily support lower production batches. Actually.
Excellent,
Okay.
Peter. Thank you very much.
You're welcome.
Thank you.